All right, guys, let's talk about dividing numbers written in scientific notation. I got an example written right here. So scientific notation, we have a leading digit, right? This number is usually less than 10 and greater than 1 times a power with a base of 10. Now, obviously, you could just type these into the calculator, especially if you got a calculator that does well with working with scientific notations, and that's always a great option. But there are really some fundamental practices at play here that really you ought to be pretty comfortable with. So let's kind of go through this problem using these tricks and fundamental principles that we should know how to use. Now, I am going to use a little bit of calculator action here as well, but I'm not just going to type them in standard or in scientific notation and do it that way. I'm going to use the strategies at play here. Okay, so one thing that I like to always do is at least in my head, I'll go ahead and show it on paper here, but I like to always think of a division problem as a fraction. And that little division symbol there, do you notice that looks like a fraction, right? That little dot is the top number, and then the fraction line, and then the dot on the bottom, right? So let's rewrite this division problem as its corresponding fraction. So the first number always goes on top, and the second number always goes on bottom, regardless of which number is bigger or smaller. Okay, so if we were going to rewrite this as its fraction, the first number in a division problem always goes on top, and the second number always goes on bottom. Now, I'm going to show you a different way to look at this problem, all right? So since we have this multiplication built into a fraction with other multiplication, what we can do here is we can look at this as being two separate multiplication problems, basically, or two separate division problems, basically. So let's just look at this piece right here. Okay, so let's kind of ignore everything else. Let's just look at 3 over 5, right? And then think of 3 over 5 being multiplied by 10 to the 15th divided by 10 to the 6th. And what this allows us to do is it allows us to use some of our fundamental principles at play here, okay? So let's just go ahead and take 3 divided by 5, right? 3 divided by 5 is going to give us 0.6, okay? And then we still have the times. So we'll carry through the times. We still have the times. And then let's use our quotient of powers property here, right? So we've got the 10 to the 15th divided by 10 to the 6th. Let's think of that as being its own fraction. So power divided by a power with the same bases, we can pass that common base along and subtract the exponents. And it's always top exponent minus bottom exponent. So that's going to be 15 minus your 6, which is going to give us a new exponent of 9. So we get an answer of 0.6 times 10 to the 9th, and this is a good answer. It's just not truly written in scientific notation because we like that leading digit to always be greater than 1 and also less than 10. So let's use our LARS acronym. Okay, so this goes for changing numbers in scientific notation. So let's see. We need to move this decimal point one spot to the right to get a number greater than 1 and also less than 10. So that's going to be left. We add to the exponent. If we move the decimal point to the right, we subtract from the exponent. So we're going to use this piece of the LARS acronym, right? If we move the decimal point to the right, however many times we move it to the right, we have to subtract that same amount of numbers from the exponent. So since we move it right 1 to get the number 6, okay, times 10, we're going to subtract 1. We moved it to the right 1, we're going to subtract 1, so we're going to change that to an 8. This number and this number are exactly the same. They are equivalent numbers, but this number is truly written in scientific notation. How's that? That's pretty nice, huh? Let's try another one. Okay, so I got another one down here. Got a division problem built out of scientific notations. Again, let's rewrite this as its own fraction. So I get 3 times 10 to the negative 7 over 8 times 10 to the negative 3. Now, same concept here. Let's think of this as being 3 over 8 times 10 to the negative 7th over 10 to the negative 3rd. Let's go ahead and work this out a piece at a time. Let's go ahead and take 3 divided by 8. That's going to give us 0.375, right? And we still have our times in between, so times, and then we got 10 to the negative 7th divided by 10 to the negative 3rd. Let's use our quotient of powers property, right? Power divided by a power. As long as they have the same bases, we can use our shortcut here, which is pass along our common base. And we're going to take negative 7 minus a negative 3, which is going to give us a minus. A minus is going to turn into a plus, right? So it's going to be a negative 7 plus 3, basically. So be careful with that. That creates double signs, right? Negative 7 minus, that's already a negative 3. So it's going to be negative 7 minus a negative 3, which turns into negative 7 plus 3, which gives us a negative 4. And that's a good answer. It's just not in true scientific notation. So let's use our LARS acronym. So we need to move this one spot to the right. And so that's going to be right 1, subtract 1. So that's going to give us 3, scoot this up here, 3.75 times 10 to the, and we have to subtract 1, right? So negative 4, it's already a negative 4. And if we subtract 1, negative 4 minus 1, that's going to give us a negative 5. And there we go. Didn't even need to use the scientific notation function on the calculator, just using our fundamental principles and a real handy powers property. We can work through these without too much calculator interaction. Pretty cool, actually. So there you go. Hope that helps. That's dividing numbers written in scientific notation.